Good afternoon, ladies and gentlemen. All right, so last week we started our new unit on oceans. And on our field trip last Monday, we had the chance to test some of the different aspects of water chemistry. We did tests like dissolved oxygen and acidity and salinity and temperature. And we talked about how those can apply to ocean water as well. And last week we really focused in on salinity and measuring how salty the water is. Today we're going to move forward and look at a few other aspects of ocean water chemistry. And the first one that we're going to talk about today is dissolved gases that are found in ocean water. There are two relatively common gases that are found in our oceans, and those are carbon dioxide and oxygen. Now, remember, when we were on that field trip a week ago, you had the opportunity to test how much oxygen was in the water. You did that test using a glass vial or tube that had a chemical in it that when you broke the glass in the water and the chemical mixed together. The chemical reacted with the oxygen in the water, causing the chemical to turn blue. And then you took a look at what shade of blue it was to determine how much oxygen was in the water. Well, although we were working in the Piscataqua River, there still is a lot of similarities between the water in the Piscataqua and ocean water because, as you know, the Piscataqua runs into the Atlantic Ocean, and on top of that, it is a tidal river where ocean water does run up into the river. And so the oxygen that is in the seawater and even in the Piscataqua River comes from basically two places. Some of that oxygen that's in the water actually comes from our atmosphere, and some of it comes from the algae that is living in the ocean. Because the air of our atmosphere actually touches the surface of the ocean, some of the oxygen that is in the air is diffused into the ocean water. So that's where some of our oxygen comes from. As the air molecules are bouncing around, some of them actually go in. Those that are touching the water may actually go into the water. Also, you have phytoplankton, and you saw some of the plankton living in the water last week, but some of those phytoplankton that live on the surface of the water, they do photosynthesis, and in the process of doing photosynthesis, they release oxygen into the water. For these reasons, there is more oxygen near the surface of the ocean. All right. Another interesting fact for you, there's actually more carbon dioxide in the ocean than there is in our atmosphere. All right, interesting little fact. We'll talk a little bit more about that actually next year in seventh grade science when we talk more about the different cycles of matter in our Earth. Another aspect of water that we are going to look at today and that you had the opportunity to test last week is the temperature of water, the temperature of ocean water. Now we know that salinity and dissolved gases affect our seawater. It affects what can live there. It affects how the characteristics of the water. But temperature also does that. For instance, warm water is less dense than cold water. So in warm water, the molecules are moving faster and they're bumping into each other more often because they have more energy. So because they bump into each other more often, there's more space in between those molecules in the warm water. However, in cold water, the molecules actually have less energy, so they're not moving as much, and because of that, they're actually closer together. Because those molecules are closer together, this makes the cold water more dense than the warm water. That warm water that is less dense stays near the surface because the less dense water sits on top of the more dense water. Again, we saw this in the lab that we did on Friday when we had dense salt water in the bottom of your beaker and less dense fresh water in the top of your beaker. Also, because there is more space between the warm water molecules, that means there's some space for oxygen molecules to get in there. And so warm water actually holds more dissolved oxygen than cold water. So you can see here that temperature affects what water is like and what different kinds of water are located in different places. Now, last week you read about the fact that the ocean has different zones at different depths. We're not really going to go into a lot of detail here about the different zones, but you will watch a video in just a few minutes that will give you some additional information about these different zones, like the surface zone, the transition zone, and the deep zone. What I do want to say is that as you go deeper, it gets colder. All right, the further down you go, the colder the water is. Another thing that we can see when it comes to the depth of the ocean is that as you go down, okay, the pressure increases. So pressure increases the further or deeper down you go. In fact, when you're down in some of the deepest parts of the ocean, the pressure can be as much as 400 times greater than the pressure, up at the surface of the ocean. Now, this is because the further down you go, the more water or water molecules that you have pushing on you. You have more water above you and all around you, and so the water molecules are pushing on you all the time, just as air molecules push on us here on the surface of the earth. Water molecules are pushing on you in the depths of the ocean, and the further down you go, the more molecules there are pushing down on you. Now, because of the cold temperatures and because of the high pressure, scientists can't just swim down and explore these deep ocean zones. Instead, they have to be able to use submersibles. These submersibles need to be strong enough to withstand the pressure. Think about it, 400 times as much pressure down in those deep parts of the ocean. If a person were to swim down there, their body could be crushed by that pressure. And so submersibles have to be made in a way to be able to withstand that pressure. They have to have very thick glass and be made of very sturdy metal. In fact, in just a few minutes, you're going to watch another video that talks about a scientist who built his own submersible. He actually built his first one when he was very young, about your age. And then he's been working with submersibles since then, exploring different parts of the ocean. All right, so ladies and gentlemen, if you happen to have missed anything in your notes, please feel free to go to my blog, rewatch this video. Also, as you watch the other two videos in a few minutes, go ahead and take notes if you like. You're not required to, and you can always go back and watch the videos later too if there was something that interested you or something you had a question about. If you have questions, feel free to write them down, and we can talk about them at another time too. For now, that is all we have in our notes for today. You can go ahead and put those away, and I will see you on Wednesday. Thank you, ladies and gentlemen.